Hey everyone, welcome back. I am Rohan Rajesh Jadhav. This is my friend Paras Mulik, our podcast guest. This podcast topic name is the cloud computing hypervisor.
Thanks, Rohan. Glad to be here. And today's topic is one of those topics that power literally everything you see on internet today. And most of the people have no idea about it even exists.
We are talking about cloud computing hypervisor. Before we got deep, I want to start it super simple, Paras. When someone has the cloud, what should they picture?
So basically, picture a giant warehouse, like thousands of servers stacked floor on ceilings, and that's what cloud is. It's just somewhere else. That means you don't physically own it or you don't physically have it in your own place, but it is somewhere around the world and you just rent it across via internet. So first, what is cloud computing? At its core, it's just accessing computer resources over the internet on demand. That means servers, storages, database, networking softwares such as owning them, but just like renting, not physically hardware owning them. Then before the cloud, if a company want to run a website or anything, they need to physically have the servers, rack them into room, maintain them, and also put the cooling, then hire IT staffs, etc., etc. So it was expensive, slow, and inflexible. So basically, you had to predict that your traffic of this month will be advanced and not. But with the cloud, computing goes to the AWS and Azure and also Google Cloud. So spin up a server in 2-3 minutes. That is, you can set up it into 2 to 3 minutes. It does not require a lot of time. So basically, you can do it very fast. And upscaling, you can upscale it whenever and however you want. And it has a pay per use. So as you pay it, you have to use it as according to you pay it.
So fundamentally renting instead of owning.
Yes, exactly. That is what the cloud's main theme is, that you don't actually own anything. I mean, you just rent it, but not physically own anything. So there are three main models. First is IaaS, which is infrastructure, which stands as infrastructure as a service. Now you rent a raw computing machine, such as servers, storages, also what we can say networkings, etc. So you manage everything on top of that. That means you rent it and also you manage everything yourself. Then the classic example of IaaS, first is AWS E2C, EC2. Then you get what do you call it, virtual machines. Then and also you decide what and how to run it. The second is PaaS, which stands for platform as a service. Now in this, you manage the platform, you build and deploy every application or whatever you want without worrying about what's underlaying the infrastructure. Then Google App Engine is also one prominent company in that field, which allows us textbook examples. Then you write your code, push it and run it. You never touch the server. Third is SaaS, which is also which stands for software as a service. Now this is the most people interact with because examples are Gmail, Zoom, etc. Now in this, what happens? You get a ready-made software and everything that the backend, the cloud, etc. all are been managed by the company itself. So you just get the browser or the application and you just set up and run it. That's it. There is nothing else in that.
And who are the big player dominating this space?
So basically, there are three big players. First is AWS, which is known as Amazon Web Services. Now this is the actual giant. That means it is very bigger in this field. Second is Microsoft Azure, and third is Google Cloud platforms. First, AWS, it leads roughly 30 to 32% of market cap. That is a very big number in this field. They invented modern cloud with EC2 back in 2006. Then Azure is the second most, which dominates in enterprise because of Microsoft integration. If your company runs Office 365 and Active Directory, Azure is natural fit. That means if you have a company or anywhere you use Microsoft products such as 365, etc., then the Microsoft Azure becomes a proper fit for your uses. Then third is Google Cloud. this is also aggressively dominating, but it's not as much as the first two. It has AI workloads also and big data. So, and also it is Google's product, so it is very highly competing. Then beyond these three, there are multiple such as Oracle Cloud, IBM Cloud, then Alibaba Cloud. These are regionally invented. That means it has specific region-wise capturing of their market caps.
Okay, now I want to get into the technical fundamental. You were mentioned a service, but how does one physical server run many difficult, I think simultaneously that visualization, right?
Exactly. So basically, visualization is fundamental technique that makes cloud computing possible. Without it, none of this actually works. So the analogy of this is, imagine you have a massive apartment or a building. So basically, one family could move in and use the whole thing. Okay, but waste of most of it. That means a in a big apartment, only you if you rent only one family, or if you sell only one flat, then the rest of the building will be waste. That means it will be of no use. So this is it. And or if you divide it into individual apartments, then it will be proper space dividing, and you can rent individually the whole building, and it will be what we can say efficiently dividing of it. So virtualization does the exact thing, but in physical servers. So you have a powerful server, let's say 62 GPU core and 512 GB of RAM. Instead of running one thing, that means a simple calculation or a program, you rent it, or suppose you divide it into 20 to 30 virtual machines, that is virtual different machines you can create. Then each virtual machine gets into one slice of CPU. That means if let's say you created 20 different machines, first machine if you gave to Ramesh, second machine if you gave to Suresh. Now you can divide it into 20 different peoples, and you can rent it 20 different peoples over the internet, and you can obviously run every operating system, dedicated operating systems and dedicated hardware you can use for the virtual system. This is what the virtualization actually works.
So from the VM perspective, it has no idea. It's sharing the hardware with other VMs.
So no, there is no idea to the VM's perspective that it is sharing. It has no idea whatsoever. So that's the elegancy of it. So the isolation is complete. That means there is a term called as VM isolation. For example, as I told before, that you create 20 different virtual machines. So those 20 different machines don't know that what is outside of their own machine. For example, you in first you have a Windows and you are running XYZ software, and in second you have Linux and you are running XYZ software. So the first Windows XYZ software will not know about the second Linux software, or even it will even not know that there is something like that there. So this term is called as VM isolation. It has different security reasons. It was created because of various security reasons, and also it is very efficient for it. If one VM gets compromised, it cannot directly affect to the others or the host. This is the whole logic behind it.
And what actually manages all of this? How does the system now, which VM gets how much CPU or memory?
Okay. So that is the thing where hypervisors step in. So basically the hypervisors actually decide what and how this all works, and that is the actual interesting process. First of all, a hypervisor, it is a software that sometimes called as virtual machine monitor, that creates and manages all the virtual machines in between the hardware and the VMs running on the top of it, and it controls the resources allocated to those. Think of it like a traffic controller in a busy airport. Dozens of planes fly by, okay, and who controls it? So that controller controls it, which is called as the hypervisor. For example, same as CPU times memory, storage, input output, then network bandwidth across all the VMs, that is being managed and calculated and properly structured by hypervisors.
Are there different type? I have header type 1 and type 2 throw around.
So yes, there are basically two main types, that is fundamental types, type 1 and type 2. Type 1 is also called as bare metal hypervisor. So these run directly on physical hardware. There is no host operating system underneath. Then the hypervisor itself effectively operates all the operating systems, and it has all the directory and privileges that how the CPU, memory, and everything will be allocated and all things. Examples are VMware EXIS, VMware ESXi, then Microsoft Hyper-V. Also, there is one more XEN. These are the three basically types. Then these are also used in data centers. So type 1 are mostly used in data centers. They are fast because there is no extra OS layer into that, adding also no overhead. They are secure because the attack is on the surface is minimal. So and there are powerful giants into this also, which are AWS, Azure, and Google Cloud, which have massive scaling into them.
So when I spin up an EC2 instance on AWS, I'm getting VM running on a type 1 hypervisor.
Yes, every single time that happens. So AWS basically builds their own custom hypervisors called as Nitro. They developed it because they needed something that is purposely built for faster and more secure within the better performance isolation than off-the-shelf solution.
Okay.
Then Azure runs modified versions of Hyper-V, and Google Cloud uses KVM, which is kernel-based virtual machine.
What about type 2?
So type 2 is a hosted hypervisor. These run on top of an existing operating system. You install it like an other application. For example, if you have installed any software, you just install it like a software or an application, such as VirtualBox, then VMware workshops, etc. Parallelly on Mac, these are two types. There are developers, students testing this. Also, you want in Linux environment, you can also use in that Windows laptops without any double booting. That means you can use in any operating system almost, right? Then you fire up VirtualBox, create a virtual machine, done. That's it. There is no extra threads on it that you have to do this and that. There is nothing like that. You just have to install it and create a virtual machine. You just have to install an operating system upon it. That is only one thing, and whichever you like you can do, and whatever testing or anything you can do it in that.
Security question: if many VMs share one physical machine, can they see its other data? Can they interfere?
This is one of the most critical aspect in a hypervisor design that sometimes cloud providers take extremely serious. It is called VM isolation, and modern hypervisors enforce strict memory boundaries. One VM absolutely cannot read memory allocated to another VMs or on the same host. The hypervisor mediates every memory access. So, and also I can tell that now there are strict attacks called as VM escapes, where malicious codes in a VM attempts to break out interact directly in a hypervisor. Also, there are multiple modern features coming against these things, such as AWS Nitro, etc. etc. Sorry, and there are multiple factors affecting these things, which you can actually try about.
So the security question: model is a layer, hypervisor isolation plus additional cloud provide controls.
Exactly, defense is the depth of it, and no signal control is relied on it entirely.
Okay, Paras, let's talk about the where this is all heading. What are the trends you are watching in a cloud and virtualization?
A few interesting developments. First, serverless and function as a service. So AWS Lambda, Azure functions, also Google Cloud functions. You don't actually manage any servers or VMs at all. You just write the function, upload it, and it runs runs when it's triggered. The cloud actually handles all the infrastructures underneath. and you pay per millisecond of execution time. Then for event driven, these are for event driven and workloads, APIs. It's incredibly cost efficient for all of these things.
Paras, this has been geniusly brilliant. Before we wrap up, what are the key things you want to people to walk away with?
So basically, there are three takeaways I would like to share. First is cloud computing. A basic idea I will give again about what a cloud computing is. So basically, you just rent a computing service over internet. You don't own it physically. You don't own a server or storage physically, anything. You just rent it, the computing, and you use it according to however you want. The second is virtualization and hypervisor. So virtualization is the physical machine that acts as many machines, and hypervisors is something that lets you do this and makes it possible. There are type 1, type 2, and those all manages everything. Then third is these are just this is not just a theory thing, it's about actually applying. Until and unless you use AWS and all that, you will not get an idea of how the scaling and how the paper use actually works in the cloud computing. So these are the things I would like to tell about this.
Brilliant, Paras. Thank you so much. Breaking this is the down so clearly. I geniusly learned a lot.
Thank you, Rohan. This was great for me to be here. Thank you.